Hello, my name is Jonathan Bisnet, and this is another in the series of op-amps, comparators, oscillators, and triggers. And in this one I'm still using an inverting amplifier, but I've done something a little different. As you'll see here, there's I've stuck a potentiometer in the feedback loop. So now I actually have split, instead of having 22K in my feedback loop from the previous video, I've got two 10K resistors, and between the two of them I have a potentiometer to ground. The main purpose behind this is just to give you an understanding of how to solve an op-amp without just using the standard formulas, because that wouldn't work on this particular one, at least not easily. So I'm going to show you how you'd go about solving this particular one. But the other interesting part here is by putting the pot in that position, I can actually tune, so to speak, or adjust the gain of this op-amp. So if we go over here and look at the circuit, you'll see we have what we had before. We have the 1 volt going through a 10K ohm resistor into the inverting input. And we actually, in this case, I have put nothing on the non-inverting input. I've just left it alone. There'll be a small input offset, but it won't be of any substantial concern. And I'm running this low enough that I'm not worried about to too much extent about the oscillations. So you'll note that at the inputs we're dealing with a virtual ground, 0 volts on both. So if we take that 1 volt dropped across 10K to 0 volts, we end up with basically a current flowing of 100 microamps. So we've got that current flowing towards the non-inverting input. Since it can't go into that input, it's going to continue up around, and it's going to go up here and go through the first 10K ohm resistor. 100 microamps across 10K is going to drop from 0 volts to -1 volt at the junction there, as you can see. And then we have ground on the other side of the 20K pot, which at this point is set to approximately 10K, about halfway through. So we go from 0 volts to -1 volt, so we're dropping a volt across that pot, which means 1 volt across 10K ohms is another 100 microamps. So now I have 100 microamps, I actually have 200 microamps flowing into that junction. By Kirchhoff's current law, I have to have 200 flowing out. So I now have 200 microamps flowing out across this other 10K ohm resistor, which now, if I go from -1 volt and subtract, well, let's go down here and look at the formulas here again. If I take that, as you can see, there's the previous one, the 0 volts minus 100 microamps times 10K ohms takes us to the -1 volt we have. Then we have coming up from ground through the potentiometer, we have 0 volts minus a -1 volt over 10K is the other 100 microamps. And then finally through the last one here, what you'll see is I've got -1 volt minus, in this case 200 microamps times 10K ohms, gives me -3 volts at my output. So that's how I would solve this op-amp. If you look at the rest of the circuit, you'll see it's pretty much like the other one. I've got a couple of caps on each of the power source and the ground, just to clean up any noise and all that I can in that area. But as a whole, after I come out of this, I should have 3 volts on my output. So going back and looking at our circuit here, we've got 1 volt going in and going across that first 10K ohm resistor. And if we look up here at the thing, we'll see we actually have about 100 microamps flowing through that first resistor. Then it's going up and going through the two resistors here. Here's one 10K, here's the other 10K, and you'll notice then I have through this black wire here, this black wire here, I have the pot, the center point of the pot connected to ground. And the pot is set at approximately 10K. I think it's actually just shy of that, it's 9 something to balance things out. But what you'll see is then coming out of that other resistor and going back to the input, so the feedback loop, you'll see if we look, we're dealing with just about 200 microamps. Not too bad. If we look over here at the scope, what we'll actually see is that the channel 2, which is our input, we're dealing with about 1.04, 1.12, somewhere in that range, so just a little over a volt. And you'll see on the output, channel 1, we're getting 3.12 volts, negative 3.12 volts. So we've got an increase times 3. So let me change the input voltage to 1.5 volts. Okay, so now I've set the input voltage to 1.5 volts. So if we go up here and look at the deal, we'll see we have 150 microamps flowing. Sorry. And then through the feedback loop, we'll see we have 302 microamps, so about double. And then on our output, if we come back over here, now we'll see that we have 1.5 volts going in, and we have negative 4.48 volts going out. So still about 3 times. So that little adjustment allowed me to adjust the output gain that I got off of this amplifier. Now I can change the that pot and get a different gain for the same input. So as I change this voltage here, or this adjustment here, what you'll see is my input voltage doesn't change dramatically, but now suddenly I can change the output voltage and take it up to, say, let's shoot for about 5 volts out of this. I keep turning here just a little bit. There we go, pretty close. So we got just about 5 volts for the same 1.52 volts of input. And as you'll see, I've still got about 150 microamps flowing through the input, but now I have close to 350 microamps flowing through the feedback. So that resistor, that potentiometer, gives me the ability to adjust this. So anyway, that's another variation on the inverting op amp. I hope you found this interesting and learned something from it. Thank you for watching.